All right, hey guys, it's Luke, and I just wanted to share with you quickly an article that came across my feed earlier today, and so I just wanted to kind of go over it with you. It's from the December 2019 American College of Sports Medicine Journal, and it's Mark Evans, Fionn McSweeney, and Aidan Brady and Brendan Egan. So brand new, just published, and just want to look at it. It's the title of the article is let me see here: No benefit of ingestion of a ketone monoester supplement on 10K running performance. So just go through the abstract real quick here. It is a free article. If you go on to the American College of Sports Medicine Journal, you can read the article in its entirety. But purpose of this article: pre-exercise ingestion of exogenous ketones alters the metabolic response to exercise, but effects on exercise performance have been equivocal. And this is what we've seen with a lot of stuff. So like a lot of like with fatty acids and things like that, like basically whatever you take in, you're going to elevate what's available for the body to utilize. But does that actually improve performance? And for most of the time, the answer has been no, not really. Whether, if you have somebody on a high carb diet, that's evidence shows over and over and over again that that's going to be the most valuable for improvement in performance. Whereas you can get the body to express more in terms of ketone bodies and things like fatty acids to spare glycogen, and the theory being that that will improve performance. And in reality, that has been really no increase in performance from really any study that I've seen. But just really quick through here. So on 2 occasions in a double-blind randomized crossover design, 8 endurance-trained runners performed 1 hour of submaximal exercise at approximately 65% VO2 max, immediately followed by a 10-kilometer self-paced time trial on a motorized treadmill. So right there, I mean, there is some issues there. Like 8 people, not a lot of people. That's not necessarily something you would base a lot on, but it does just give you a glimpse into what people are doing. And then the 65% VO2 max. So I would just wonder what level of runners these people are. So if they're highly trained, 65% is going to be a fairly moderate run, nothing crazy. 65% on the other hand for a beginning runner is going to be pretty high intensity. That's going to probably be closer to marathon intensity. It says they're endurance trained, but you'd have to look and see what that actually means for the person. So anyway, 8% carbohydrate electrolyte solution was consumed before, during exercise, either alone or with 573 milligrams per kilogram of a ketone supplement. Expired air, heart rate, RPE were monitored during submaximal exercise. Serial venous blood samples were assayed for plasma glucose, lactate, and beta hydroxybutyrate concentration, which is the ketone measurement. Results: carbohydrate and ketone produced plasma hydroxybutyrate concentrations of approximately 1 to 1.3 millimoles during exercise. Plasma blood glucose and lactate concentrations were similar during exercise in both trials. VO2, running economy, respiratory exchange ratio, heart rate, and RPE were also similar between trials. Performance in the 10K time trial was not different between the two groups, with a 95% confidence level, 2,200 to 2,600 seconds. And then the carbohydrate and placebo, the mean was 24:22. So let me see here. Okay, so the mean time was 2,400 seconds for the carbohydrate and ketone, and it was 24:22 for the placebo group. So no statistical difference. Cognitive performance was measured by reaction time, and multitasking tests did not alter between trials. So conclusions: compared with the carbohydrate alone, co-ingestion of ketone bodies by endurance-trained athletes elevated the ketone concentrations, but did not improve 10-kilometer time trial performance or cognitive performance. So again, that's what we see, and that's what we really see now. I will say this: I don't understand necessarily the hour before and then jumping into a time trial. I don't necessarily understand what the purpose of that was, but I do think it does it. Because normally I would say, well, 10K time trial, that's really not going to tell a marathoner too much. So you extrapolate that out. Maybe there is some benefit to the ketone bodies, but the saying that you've already run for an hour to moderate intensity and then run a 10K time trial, my assumption is that they're just trying to get the glycogen stores down and then um, see what happens with that, because the whole premise of that was they kept referencing was the glycogen sparing effect of ketone bodies. But really ultimately what we see is that if we have more of that in our diet or what we're taking in, then yes, it's going to be more present in our bloodstream and things like that, but it doesn't necessarily mean that it's actually going to be utilized. And so I think we have to be careful of that. So, I say the same thing with the fat, increasing the fat in the diet. Yes, those things are going to be more available for energy usage, but does that mean that the performance is going to be improved? And so far, we really haven't seen that. We do see that you're going to burn those things more than the carbohydrate, but it doesn't necessarily translate into performance. So you have to be careful of what is available versus what is actually happening. So just thought that was interesting and wanted to share with you guys. All right, talk to you later. Bye-bye.